Hello everyone! Today, I'll be demonstrating how we can implement basic logic gates using PLC programming in GX Works2. I will explain the purpose of each gate, show the ladder diagram I created, and then test it by turning the inputs on and off. Along the way, I also point out how the results match their truth tables. AND gate. The AND gate produces an output only if all inputs are on. In my ladder diagram, I connected two inputs in series. When I press both switches, the output lamp turns on. Even if one switch is off, the lamp remains off. This matches the end truth table, where the only condition that gives A1 is when both inputs are 1. OR gate. The OR gate produces an output if at least one input is on. In the ladder diagram, I connected two inputs in parallel. Pressing either switch will allow current to flow and the lamp turns on. The only time the lamp is off is when both inputs are off. NOT gate. The NOT gate, also called an inverter, flips the input. Here, I use a normally closed contact for the input. When the switch is not pressed, the lamp stays on. But once I press the switch, the lamp turns off. So, input 0 gives output 1, and input 1 gives output 0, just like the truth table of a NOT gate. NAND gate. The NAND gate stands for NOT AND. In my ladder diagram, I use two normally closed contacts in parallel with a regular coil. Here's how it works. If both inputs are on, both normally closed contacts open and the coil turns off. In all other cases, at least one normally closed contact stays closed, so the coil energizes. This creates the NAND function, where the output is on unless both inputs are on. You can also see the truth table matches perfectly. It is the opposite of AND gate. NOR gate. The NOR gate stands for NOT OR. For the NOR gate, I use two normally closed contacts in series with a regular coil. If both inputs are off, both normally closed contacts stay closed, and the coil turns on. If any input is on, one normally closed contact opens, and the coil goes off. This matches the NOR truth table, which is the opposite of OR. XOR gate. The XOR gate gives an output only when the inputs are different. For my ladder diagram, I used a combination of parallel and series contacts. One branch checks switch 1 on and switch 2 off, while the other branch checks switch 1 off and switch 2 on. These branches are then connected in parallel to the same coil. This makes the coil energize only when the inputs are different. In the truth table, you can see the output is 1 only when exactly one input is on. And that concludes our demonstration of the basic logic gates using PLC programming in GX Works2. You've seen how each gate, AND, OR, NOT, NAND, NOR, and XOR behaves in the ladder diagram, and we compared the results with their truth tables to confirm the logic. Thank you for watching.